This session is Microsoft Systems Architecture, so I hope everybody's in the right one. My name's John Dawson. I'm the Group Manager of the Microsoft Systems Architecture team. It's a team within the Windows product group, and in effect we do infrastructure architecture guidance. That's what we're all about. And it's that I want to try and get across to you today in terms of, so what is it MSA has got to offer? What's the value in it? How can I use it? And it's very much that's the theme of what I want to get across. I've given out a CD of all our materials, and you've got a logical diagram of the architecture. That's purely as reference for you as we're going through, just in case you can't make things out on the screen. I'm not going to dive deep in terms of technical reasoning as to why that's like it is. Certainly I can answer questions, but the fundamental thing I want to get across is, so what is it? How do I leverage it? You know, how is it going to help me in what I do? And hopefully they're the kind of questions that you've got and you want answered. Please feel free to stop me as I'm going through and ask questions. My goal or my idea of success for this is if that you go away understanding precisely what we offer you, and you understand precisely what you can and can't do with that in terms of helping you in your environment, working with your customers, etc. So the kind of things I want to cover is firstly the problem space. So what kind of problems do we think we're solving for people here with MSA? Just to make sure we all understand where we're sort of targeting this kind of guidance. Then actually talk about our approach. What's our approach to architecture? How do we go about developing it? And then go on to say explicitly what it is. What is Microsoft Systems Architecture? What do we deliver to you? All the sort of why, what, where, how, all them sort of questions you might have. And it'll allow you to ask the but what if. So that's your bit. Please feel free to try and make it relevant to you so that you go away understanding what it is and how it's going to be helpful to you in your job. Then I'll go on to describe MSA 2.0 a little bit. That's a release that we've recently made, which is based on Windows Server 2003. And I'll use that diagram as a means to sort of build the architecture and just get across some sort of key points as to how it's built, what the implications are of what it looks like, and hence how you can leverage it. And then just a wrap up. Okay. Can you just pass the CD back, please? Can you just pass one back? Thanks. Okay, so the first thing I want to hit you with before we start getting into, you know, business problems, technical problems, those kind of issues, is just sort of a blam. Here it is. Here's the diagram. This is Microsoft Systems Architecture. And all I want you to get from this really is an understanding of the breadth and depth of what we're talking about here. So this is our logical architecture, not our physical. The server icons in here represent services, not servers. So it doesn't show two if it's clustered and those kind of issues. Simply representing the distribution of services in a complex IT infrastructure. Right? So we've got the kind of zoning you'd expect for perimeters and borders, internal networks, remote access, branch offices, all that kind of separation, and how do all these services communicate across them. This is in effect the enterprise problem space, and this is in effect what we've developed and the guidance around this that we're shipping to help. So that's the big picture I want to get in your mind, and hence the diagram as well. So as we're going through it, everything I'm talking about is in effect related to this diagram. This is the sort of high-level view of all our guidance, whether it's relevant to an architect or whether it's relevant to an implementer who sat at a keyboard and needs to solve a problem. So there's our big picture, IT infrastructure for the enterprise. So enterprise problems, what do we think we're trying to solve with Microsoft Systems Architecture? So firstly is around IT alignment. That's the IT part of an organization and the business part of an organization. Now, I don't know if this is what you find either in your organizations or with the customers you work with, but quite often what I find is that there's this almost an invisible wall that exists between the business side of an organization and the IT side. The guys who solve business problems with applications, and then the guys who are supposed to support them by putting in available infrastructures that are secure and scalable and all that good stuff. And usually when that wall exists and the business guys throw an application over to the IT guys, then it's a case of, ooh, how am I going to get this out into production? And often that's when the problems are found. and they're not found up front. And again, that's a space that we're trying to help with so that we can have an architected approach to solutions that should allow for this contract between business and IT to better get on the same page, to better enable the rolling out of applications into production. Second is around, connected to that, but it's around the agility that's sort of demanded within modern organizations. Business solutions, everybody wants to get them out quick, they want to get them out in a cost-effective fashion, and often operating in an ad hoc fashion whereby it's 20 servers here to solve this problem, 20 servers here to solve this problem. You can lead into this environment where you've got a very difficult to manage and very difficult to grow or change IT infrastructure. And again, a lot of conversations we have with customers talk about treating or trying to treat IT infrastructure as an asset to the organization in terms of enabling the business, rather than it being seen as a cost overhead or that nasty thing you've got to do before you roll an application out into production. IT projects, there was a survey done, I don't know whether it was a Standish or a Gartner, it was one of those sort of industry analyst surveys that was done, that polled various enterprise organizations in terms of what they considered to be their ratio of successful IT projects. What they found was that 75% of IT projects could be considered unsuccessful. So that could mean not only that they just failed and they didn't happen, but also that they weren't to budget, they weren't to time, and they were just not successful, basically. So it's a very, very high percentage of projects. And out of that high percentage, what was found is that 50% of the time was often churn time. So what I mean by that is in effect reinventing wheels, solving problems that should have been solved somewhere else. Right, so I came out of the consulting world. Before I joined Microsoft, I was at Siemens, I was at Unisys and Tandem, organizations like that doing consulting work. And quite often the question I would get is, you know, when I'm in a customer situation trying to solve a problem for them, the question is, surely this problem's been solved somewhere before. You know, it's Microsoft systems, this is stuff's global. You know, why am I paying you to solve this problem? And me as a consultant on site, I didn't really want to spend my time trying to get some of these technical things working when you're just pulling your hair out thinking, this stuff should just work. I'm fed up of trying to get this stuff working. You expect it to work. Now, someone somewhere has made it work. Right, so this is the churn time that we're trying to overcome by putting together best practice guidance under the banner of an architecture, so that makes it sort of an end-to-end solution in the enterprise space, to say, well, this is the proposed best practice for the way to do things. I'll give you an example. I mean, I don't know if anybody's dealt with these technologies, but if you try and get Application Center 2000 working with network load balancing, and you're trying to use a compact NIC teaming driver, so that's two network interface cards you're trying to make appear logically as one, and you're doing that connected to a Cisco switch. Now, if anybody's ever been in that situation, I've been through that pain, and it took days and days and days to get that working. And that's a classic example of me as a consultant saying, I don't want to fix this stuff over and over again, and the customer saying to me, why am I paying you to fix that stuff? These products should just work. So the issues are not only accumulating best practice and finding a means to distribute that, but it's solving the problem up front in a real world environment, tested and proven, not a white paper, and shipping that content out so that people can reuse it. Wow, is that going to impact churn time? So from the perspective of IT projects, there's still high value work to be done as a consultant on site, but you sort of want to raise the bar a bit. Don't deal with the underlying things because product X, you know, a network load balancing and a switch have got issues working together. You want to be working at a much higher level than that as a consultant. And that's, again, what we're trying to enable. And lastly, I would say Microsoft's not exactly helped in this area, you know, ad hoc and informal growth. It's been very much the norm, I would say, over the last 5 years where customers got a solution, they want a problem, they want to throw a solution at it, and that again has been, well, we need 20 servers to run this business application, or we need 10 servers here, we need 10 servers there, and you end up very much with this proliferation that gets to a point where customers feel as though they're a little bit out of control of their IT infrastructure. So the more you deal things in this very ad hoc fashion, then the more you give yourself the opportunity to go against some kind of consistent security architecture, or go against some kind of manageability standards that you've set, because you're rolling out multiple applications in a fashion that's just not a concerted effort. So they're the kind of problems that we're trying to deal with, and I'd suggest we're trying to deal with them in two ways, and this is a fundamental thing that I'll probably be trying to hammer home as we're going through the slides. The two ways are, firstly, strategically. The strategic approach is, say, well, let's formalize how we do things. Let's create that contract between business and IT for how infrastructure is going to support applications and understand our deployment architecture, i.e., we build an application, it looks like this with all these components. How do I get that onto my IT infrastructure? I mean, that's one of the issues, but the other issue is it's distributed over a complex, multi-tiered infrastructure. How do I ensure that all the right holes are poked through the right firewalls, all the communications set right at the switch layer, all the routing's right? How do I ensure that up front? So that's just the strategic approach to using MSA, is getting those contracts in place so we can build better applications that are more sympathetic to the IT infrastructure that support them. The tactical side of it, so we produce architecture. Architecture's wonderful stuff, but I would say it's only wonderful or made more wonderful if it's actually proven in a lab. If you ship a white paper saying this is a good way to do stuff, that's useful reference material. If you ship some architectural guidance saying, here are all your design options, here's all your pros and cons, here's why you'd choose this one, this was our scenario we chose, this is our option we chose, and this is why. If you've got all that ammunition, plus the build guidance, plus the test guidance, the test results for what we found in our lab, it just adds value completely to that architecture because someone's done it. And again, that's the space that we're trying to help in. So the technology problems. Many organizations look like this. This is the sort of napkin syndrome of feeling out of control with technology. Quite a few organizations, we have here a facility called in fact we're in it now, the Executive Briefing Center. And we speak to a lot of customers here about what their problems are. Now they're not all in a situation where they feel as though they're in a complete mess, but it's a very, very consistent theme that people are wanting to standardize their infrastructure, and they're wanting to rationalize their infrastructure, i.e. consolidate. Because of that, they've had this ad hoc and informal growth. So there's quite a few organizations feel as though this is their problem, in that they've got a sketch on a napkin somewhere, and that's the level of control they've got in terms of what their IT infrastructure looks like. Moving that forward is obviously going to be very difficult. And the factors that are hurting everybody now, across the top, different sort of complex ways to geographically distribute services now. And that makes life very difficult in terms of IT infrastructure. And across the bottom, the different kinds of users that we needed to cater with now. More of the sort of mobile user. And boy, does that introduce you problems for the IT infrastructure. How are you going to securely connect customers, partners, employees when they're coming in a remote fashion? So there's many, many scenarios that are making life difficult for us from a technology perspective. So hopefully now you understand the problem space, i.e. the enterprise, the kind of business issues of rolling out new solutions to problems, and the kind of ad hoc and informal growth of IT infrastructure, the need to standardize, the need to consolidate. So what's the formal definition of Microsoft Systems Architecture? Across the top there, technology architecture for the enterprise. I would caveat that with Microsoft-centric, because what you don't see in there at the moment are things like IBM mainframes and Unix systems. And of course, we completely acknowledge that those things are out there, but we've got to start somewhere in terms of defining the Microsoft architected fashion for rolling out our solutions, and then take into consideration the fact that they need to integrate with existing environments. The more long-winded definition that's underneath it there, let me just call out a few key things. Firstly, architecture blueprints and implementation guidance. That's alluding to what I was saying. Architecture is wonderful stuff, but if you can show how you've implemented that architecture and deliver the guidance that tells someone how to implement it, then it just completely adds value to the architecture because it's tested and proven, which is the next statement there, tested and proven in the lab with hardware and software partners. So that's the other key issue here. This is not just Microsoft getting in a lab and saying, this is cool architecture, do this stuff. Because networking, that's not our core competence. You know, high-end storage systems, they're not our core competence. So we need to work with people like Cisco, HP, EMC, Dell, all those names that you'd kind of expect to hear. We work with them very much. So we build out a large lab environment, which is in effect the logical architecture you've got is a logical architecture of our lab. Pretty extensive, high investment. Without partners, we can't do that. So it's not just the development aspect, though, where partners are important to us. It's the whole delivery and further development. So we work with Avanade, CGY, all those partners to do this as more as a joint effort, and then to offer up the guidance as a means to help that consultant force with that partner to deliver services based on MSA. Now the other aspect is customization. If I take an example of Unisys, so what you're seeing here in terms of this logical architecture is what we did in our labs. It's what Microsoft did in our own labs to prove out the architecture. So Unisys might come along, and I don't know if you're familiar with their ES7000 device, but it's like a data center consolidation server, a very high-end server that's used as the Windows data center version. They want to showcase that kind of technology. Well, that's absolutely great thing for them to do, to take MSA, impart their technology on it, and do a version of MSA that is relevant to their technologies, and goes above and beyond what we've done. So another example there, they've done a disaster recovery solution. So they took, in effect, our architecture, they built it out twice, and added all the necessary technologies to allow a disaster recovery solution. So they've got pre-built architectural guidance right down to the build level, telling someone how to build out data centers that do everything from service level right up to data center level failover, up to 200 kilometers. So that's a great value add. That is an area that Microsoft's just not got the competency in to go that far. I mean, that's not our core skill. So it's great that the partners take this and take it further. So what's our approach? I've already sort of discussed the partners there, servers, storage, network type partners, but there is also software partners. Software, so for an example, backup and restore. I don't think we'd necessarily suggest that the Microsoft backup tool that comes with the operating system is probably the best enterprise backup tool that you want to use. So we're trying to be realistic about what we've got. There is always good circumstances where you might want to use that as a tool, but I would suggest in an enterprise backup scenario, you're probably going to be looking at something else. That's an example where we actually partner with a third party to get an enterprise level backup solution. So this is not Microsoft just saying, thou shalt use Microsoft technologies. It's us saying, wherever they are most appropriate, we will give you the guidance to implement them. I'm going to give another example. I'm sort of flipping back to the hardware side of it. But we always have discussions around network load balancing as a technology, and the suitability of network load balancing within the data center. So our approach is not just to say, hey, it can do the job, just install it, because we've got the guidance. What we did up front was to see where that technology should be best implemented. What's it good at? What are the scenarios that we need to showcase because it can be implemented and do the job very effectively? So we've actually got, in our lab, network load balancing implemented for things like VPN servers. 2 VPN servers in a highly available configuration. 2 of them can actually scale to quite high numbers of VPN users. That's a great example of where network load balancing is an incredibly cost-effective and simplistic way to give you high availability and some kind of scale on a VPN service. Now, if you contrast that to web tiers, web front end, if you're Amazon.com, I would expect that they probably wouldn't want to use network load balancing for their 200 front-end servers. Likewise, in our environment, we've actually used the Cisco load balancing device for the perimeter because that's a much more appropriate technology for the kind of scaling demands. So we're trying to be realistic about what we do. So we get with all the appropriate partners, and in effect then oh, the build's gone wrong. Well, you'll just have to imagine it was really good. So what we do, we get with these guys and we build out labs. The next picture was just supposed to be a representation of a lab, and it wasn't very good anyway, so you've not missed much. So we build out labs with them, and that's what it's all about for us. Can't stress that enough. Tested and proven is in all our guidance, and I think that's a real value to what we do. So once we've built out labs, the key thing that we've got to do is provide guidance in relevant scenarios so people can understand how it applies. Right? So in previous materials that we've distributed around the internet data center, and the enterprise data center, they were very sort of siloed into a specific scenario. But now with Microsoft Systems Architecture 2.0, we're actually treating the enterprise as a single entity that's just got different scenarios within it. You can always boil it down to there are customers, so you've got an internet presence maybe to reach customers. There are partners, so you've got maybe semi-trusted users that you want to give a different sort of access to. And you've got employees, and employees that are geographically distributed. So you've got this varying community that you need to deal with. And you can typically boil that down into the kind of scenarios we've got up there. Branch office networks, extranets, internets, and then this logical concept of a department. So we deliver our guidance into these scenarios. Everything we do, so we talked about architecture, everything we do is based upon architectural principles. That's an absolute must. I'll not go through all of these, but I'll give you a flavor of what I mean by that. So, scalability. Scaling, whether it be in, let's say, a web tier or a database tier, SQL backend or an IIS server, there's going to be very, very different approaches to the way you scale them. I mentioned the S7000 earlier. It might be a great device to have a scale-up strategy for SQL Server. But that's a very, very different approach as to how you would scale up and scale out IIS front ends. It's those kind of considerations that we've absolutely got to take into or implant within the architecture. So what are my design options? What are the pros and cons of those design options? And then given some requirements, what decision am I going to make and why? I mean, that is fundamentally what it boils down to. So that gives people the tools to make the decisions they need to make for a specific customer engagement, which is another point I can't stress enough. What the diagram's got on it there for what we did in our lab, this is not Microsoft saying thou shalt do that. It's not that at all. This is just how we proved the architecture. What we're expecting you to be able to do is take this away and use all the knowledge and process and decision that went into this to make the decisions you need to make for your customers. I can't stress that enough. So other things, security. Security, you know, is like a big issue for Microsoft at the moment. The key thing I would suggest out of something like Microsoft Systems Architecture is we've got this architected approach to security. What does that mean? For us, it means we go through a process of identifying threats and risks, then we identify a mitigation strategy to those, and for us, that's termed defense in depth, and then we apply that in terms of how we build the architecture. So the key thing for me, I mean, if you want to boil that down to what does that mean, the key thing for me, if you think about all the patches that are coming out at the moment, it's a very, very difficult job for people to keep their servers up to date with the patches when you're in a very large distributed environment. We know that. But it's got to be done. But that patch is patching a vulnerability, right? And what I would say is more important is the exploitation of that vulnerability. So that's where we're targeting defense in depth as an approach, to try and say to people, it's much, much better to save yourself from vulnerability and allow yourself the breathing space to deal with your, save yourself from exploitation and avoid the vulnerability being exploited. Sorry, that didn't come out quite right. But the theory is, if you apply defense in-depth strategy, so you apply security in a multi-layered approach, the chances that a vulnerability in your environment can get exploited are absolutely minimized. We've just had a recent external security penetration test done by a company called Foundstone, third-party security company. They came in and did some penetration testing on our environment. Now, their penetration testing started a few months after our developments ended. And in that few months, we hadn't applied some of the latest patches. So their conclusion to their security penetration testing was that Microsoft Systems Architecture is a great implementation of defense in depth. They did find that we'd got some vulnerabilities out there because we'd not got some patches applied, but they absolutely could not exploit those vulnerabilities. So some examples of that, when a hacker gets into an environment, quite often with a lot of these vulnerabilities, they get in so that they can then go back out and get some tools like lightweight FTP tools to bring nasty things back into your environment, and then that enables them to spread within your environment. So obviously, if you go back out of an environment, that's the means to stop someone doing that. That's defense in depth. Not only can you stop them getting in, but another layer of defense needs to be there to stop them getting back out again. The other thing, if they're running things on your server once they've got in, that kind of implies they've got the rights to run executables. So what's the lockdown policy on that server? Another layer of a defense in depth strategy. So I can't stress that enough. We absolutely push defense in depth and say, worry about exploitation. And then you have separate strategies like patch management mechanisms to then worry about putting the band-aids on the vulnerabilities. Availability, that's another good point. We aim for no single point of failure. So to me, that's like the high ground. That's doing it the hard way to try and prove the hardest approach to it. But in your environment, you may well say, well, we've got 2 Cisco switches, for example. They're about $80,000, $90,000 each. Now, for your environment, you might say, well, Cisco tells me that those switches are 99.999% available, and I'm completely okay with that. That's enough for me. I don't want to buy 2 switches. So if that's your decision, that's absolutely fine. You know, again, it's not what we did in our lab, but as long as you went through the process of understanding the risk implications of doing that and the ripple effect of doing that, i.e., if you haven't got 2 switches, there's absolutely no point in NIC teaming, because then you'd end up with 2 wires going to the same switch, so you've not catered for switch failure. All you've catered for is wire failure, in effect. So there's a ripple effect and there's a risk. As long as that is understood, then there's absolutely no reason why you wouldn't let business reasons or technical constraints govern your decision as to how you want to do it in your environment. Other things, deployment, rapid time to deploy. We spend a lot of time on automated deployment techniques. I mean, not only because that's valuable guidance to give out to people, how did we stand up our lab in the most efficient fashion, but it helps us as well through our test cycles. I mean, we want to test this stuff as quickly as we can, so the quicker that we can restand our labs, then the quicker we're going to get through the test cycles. But the resultant guidance of us doing that I would liken it very much to a great sample app. When you get Visual Studio and you install it, there's some sample apps. You would never go into production with them, but boy, they're going to save you some time when you want to look at tools and techniques to help you solve a problem. Similar thing, we've got automated deployment mechanisms, and they're going to be a great sample to help you build automated deployment. Standardized, this is a word that I'm personally hearing all the time at the moment. Is it? So let me ask you. I've already talked about the strategic approach to the use of MSA and the concept of standardization and forming this contract between business and IT. Is that something that you are hearing? Is there any of you finding that either in your organization or the customers you speak to? Standardization, consolidation, this contract between business and IT. Does that resonate with any of you? Yeah. I mean, that's generally what I hear a lot when we speak to customers. So you might be thinking, well, this is all cool, you know, it's big. Oof, you know, that's a big job to do that, and it is. So why do we do it? And another reason you might ask why is we actually ship all this for free. It's all on TechNet. It's no product. You know, there's no cost associated with it. So that's another reason. So, you know, why? So multiple reasons why. Firstly, the need for standardization. I would suggest that a lot of issues that we find in the enterprise space with the deployment of Microsoft products is not only the fact that maybe Microsoft's not done enough in terms of integration guidance, but also I think because we come out of the desktop space, there's a lot of feeling that setup.exe in a wizard is going to get what you need when you implement Microsoft products. Now that's ignoring the fact as to whether it's a small environment for 10 users or whether it's a 300,000 Exchange server rollout. I think there still is a little bit of that mentality hanging over, and I think it's our job to try and put the right guidance in place. I suppose you could equate it to try and bring a little bit of the mainframe mentality into the implementation of Microsoft products, because the setup.exe and a wizard is not necessarily going to get what you need for a full end-to-end solution, obviously. Secondly there, seeding systems integrators and partners. So this is Microsoft doing it with partners, as I described earlier, which is important, but we're not doing it for the benefit of Microsoft field. We're doing it for the benefit of Microsoft and all our partners, so that you can leverage this in your environments to say, well, what is a standardized approach to doing it? I mean, take Exchange as an example. If you've ever dabbled with that as a product, you'll know that not only is it a complex product, but it has a significant impact on your infrastructure, you know, Active Directory. So wouldn't it be great if there was something more standardized telling you, well, this is a good way to approach it, and this is what we did in our labs and tested and proven, and this is how it worked. That would be a great sort of jump start to your implementation projects and your architecture and design exercises. Thirdly there, quite obvious, if you've got that kind of jump start to your projects, whether it be from an architecture perspective or whether it be leveraging the automated deployment techniques or the build guidance or the testing methodology, you're going to get savings in terms of the time it takes to implement. That reduces the cost, it reduces the time to market. Now, there is an argument that kind of suggests, well, we don't really care how long it takes. We want good, long, healthy projects with our customers. But I would kind of say, well, we all seem to want to do the valuable high-end guidance. That's the good stuff. That allows you to work with customers and then go on to solve more and more of the customer's problems. So what we're trying to do is, connected to what I was talking about earlier with those problems with putting some technologies together and the issues of Microsoft and partner product integration, you don't want to deal with those problems necessarily. You want to deal with the customer's problem, not the technology problems. And lastly, this is sort of, so why do we do it? Why does Microsoft do this? Our group is very much about product improvement. So if you think about it, think of this diagram you've got in front of you. When we put all these products together in this fashion, not only the Microsoft products, but our partner products, wow, what an opportunity to find integration issues. The product groups do a great job of testing their individual products, but they're obviously not going to implement all the scenarios that typical customers might implement. So what we've developed is this model enterprise, and it's an end-to-end solution that includes all these services. So we not only run all the tests for things like security, availability, scalability, stuff like that. We also run the functional tests, i.e. does this product work, and then we run the sort of day-in-the-life type tests. We put a very mixed workload together and run the environment as though it was an enterprise. And we do find issues. We find issues with our own products. We've found issues with partner products. Nortel, Cisco, they've got fixes in their load balancers, their switches and routers, purely as a result of going through this integration exercise. So all that is good stuff. And it's not just the lower level, the bugs that are important. It's like the fit for purpose type problems as well. The design changes that you want to impact. A good example, ISA server. In that diagram that you've got in front of you, ISA server is playing a great role as a perimeter firewall. It does a good job there. Having the ability to go up to layer 7 in a perimeter firewall is a good thing. But the internal firewall is a Cisco firewall. And that's because Cisco hardware did a better job or was more capable than ISA server in that specific environment based on our requirements. Right? But so obviously we've had a lot of feedback with the ISA server team, suggested scenarios where their product could improve, and the next version of ISA server, Server 2004, is going to be a way, way more capable product. And check it out when you start seeing the information that's appearing. I believe the release is sort of mid-year next year, and that is going to be a way more capable product of dealing with these multi-legged, complex environments that internal firewalls need to deal with. So product improvement, fit for purpose, that's very much what we're about. So what do we give you to help you do this? Let me show you first while I'm talking. So two fundamental parts, reference architecture and the implementation guidance. Now the reference, I've got 2 of the 3 books here, so the reference architecture is pretty significant. So what we go through is firstly architectural blueprints. So in here there's chapters around networking, security, management, application infrastructure, storage infrastructure. It's that kind of underlying architectural concepts that need to be in place. These are in effect the principles on which we build architecture or which we deploy services, which leads to the next piece, which is the service blueprints. We've got 2 similar books like this, and these are all the core IT services: Active Directory, Wins, DNS, DHCP, certificate services, proxies, firewalls, all that kind of stuff which you could say is lowest common denominator. Just about any environment's going to have this stuff in it because that enables business solutions. Right? So it's about 16 chapters or something like that, and in each of these, like directory services here for example, there's going to be options. You could do it like this, here's the pros and cons. You could do it like that. Here's the pros and cons. So it's that kind of information that architects and designers generally thrive on in terms of, so, you know, what options are available to me here to produce the best design. So that's the reference blueprint, the reference architecture. And I've not mentioned any of the partners in there. The reference architecture is agnostic of technology. So it's not at that point that we talk about Cisco or HP or anything, basically. That's agnostic of the technology. And then when we go into the implementation guidance, that's when we've got together with a bunch of partners, we define an enterprise model, then we make some decisions. So the first guide there is a planning guide. That's got in it the decisions we made, i.e. what are we going to implement and why are we going to do that? Yeah, so that is, again, the designer, that's the valuable content for him. Once we've made those kind of decisions, we can go on to build guidance. That's step-by-step guidance, in effect clickstream. So how did we build out that infrastructure? Every product, the build order, which I consider to be the most valuable. If you're doing solution level install, you need to know how all the products fit together. What have I got to do first, second, third, fifth? What have I got to wait for before I do to do something else before I carry on? It's that's real high value content. And then we add to that testing methodology. What's our approach to testing this? What are the test cases, test scenarios? And for all those test cases, what were our test results? Now, in terms of test, the thing I will sort of stress again, we do testing of what we call like non-functional things, like availability, scalability. Functional things, which is, does the product do its job? And then the sort of the day in the life concept of, can it deal with a complex mixed workload? But our testing is not for things like performance, benchmarking. The products groups will tell you how fast SQL can go or how fast web servers can go. What we're trying to tell you is how best to put them together. So for us, it's not performance, it's like performant. It is well capable of performing in a given architecture. Lastly, and I've touched on it earlier, a fundamental part of what we do is supplying all this to our partners. So if our partners want to take our guidance and do something with it, extend it, i.e. the disaster recovery solution I was talking about earlier, then we give them everything necessary to enable them to do that. We also have got to put in place some kind of qualification program. We've got to ensure some kind of standards. So we have a partner qualification program. Oops, sorry, I thought that was the next slide. And within that program, we define a quality bar. We define some architectural requirements that must be met, the documentation set as it needs to be supplied, and the partners go away and do their own developments. And we've had a significant number of partners that have done this. And all we're doing, in effect, is being that quality bar and then providing the logo so that we can all ship guidance under the same umbrella. Microsoft Systems Architecture obviously being that umbrella. So the guidance itself, what I'm trying to suggest here is, so that there's a lot, right? This is 2 out of 3 parts of the reference architecture. And there's also an implementation guide. We've got approximately 3,000 pages. So you might think, wow, that's a lot of information. How am I going to find what I need? We had a lot of feedback from our earlier materials, our 1.5 materials, saying that things were hard to find. If you wanted to implement a secure VPN solution for branch office networks, you probably got a lot of thumbing to go through to find what you wanted. We've tried to address that by treating our guidance very much on the IT services basis. And then within the service, worrying about the scenarios. So you should, if you're interested in secure VPN for a branch office network, be able to go to the VPN service, and within the VPN service, see the section that's relevant to branch offices. And so hopefully our guidance is much more modular, it's much more discoverable, and it's much more of a reference at a more granular level. You know what I'm saying? So we're trying to overcome the fact of people seeing this and thinking, wow, that's massive. All I'm interested in is this little piece. You know, the guidance is there. I mean, the value is that this little piece is in a wider context. It's been end-to-end solution tested. So as long as we make the guidance such that you can discover what you're interested in, then, you know, it's going to be a quick win for you. Now, one thing I will add, all these scenarios, there's a lot to do there. We've not got through all them yet. We've covered the corporate scenario, the central centralization of enterprise-wide IT services, and we've done some work around a branch office, but that's not of the scale of what you might think of like a bank branch office where there's a lot of local services. And the others scenarios, we're getting there. We have to sort of chew off pieces that we can manage and extend the guidance to other scenarios, and that's what we're working on now. So partners, these are all the people we work with, kind of names you'd expect to see. One thing I will call out, let me just check, oh here it is. So one thing I will call out in terms of partners and some of the unique things that's happened, NEC for example, that's a great example of where what we do in our labs based on the partners that we picked might not be relevant for the Japanese market. The kind of partners that they work with there is a very different mix of partners than we work with here. So what NEC did was take our guidance. I didn't know before this but NEC actually produced their own storage, their own networking, their own servers. They do the whole a whole range of infrastructure hardware, and they did their own equivalent guidance but did it in Japanese. So they've localized it and they've made it very specific to their market based on local technologies. Right? So if you were working in the Japanese market, then obviously that's going to be very relevant to you. Equivalent example is Fujitsu Siemens. They took the guidance, they didn't actually do it in German, they chose to stay in English, but they've done it in a fashion that Fujitsu Siemens services organization are now using this to underpin all their services targeted at the data center, because it's very, very specific to their locality. The logo at the top there is the logo that we give to the partners for them to distribute the guidance. If you go to emc.com/MSA, you'll find their stuff. Dell.com/MSA, you'll find their stuff. They're not all quite as straightforward as /MSA, unfortunately. Unisys is data center /MSA, but it's like this community of guidance that's being developed around infrastructure. And the fact that it is a community that includes all the partners, again, to me, really adds the value to what it is. Yeah? So when you say logo certified,
distinguish between what kind of guidance you're providing here from an architecture perspective. Are these all logo certified products that we're talking about, or is there some mixture here?
I'm not so sure what you mean by logo certified. Do you mean like the hardware compatibility list and things like that?
There's also products that I thought that, at least what I'm reading online, that can be qualified a certain way, and they need, say, certain standards and testing. There's a certain testing process that those products have to go through.
Right.
So when they become certified, they have a certain amount of scalability that when you do scale them, you don't suffer, say, with an availability kind of
right.
If they scale on those kinds of dimensions.
This is complementary to that. It's not part of that, and it doesn't replace that either. In that this is very much about the logo here is given because there's sort of architectural compliance in effect, and it's a qualification, not a certification. Because what do you certify? I mean, we're not certifying it's 5 nines or any of that stuff. What we're saying is that the partner has gone through the pain necessary to produce architectural guidance and prove it out, and deliver the guidance in a quality fashion that is consistent with MSA.
Solutions that are provided as a combination of products that are being recommended. Some of them might be certified, some of them might not.
Yeah.
Okay.
Yes, but that's a different issue.
Okay.
Yeah. Good. So all this has happened. On here was the DR solution that I mentioned earlier, things that have been localized for the geography, and I think it adds great value to the program in that we do, as a community, ship infrastructure architecture guidance. So how do we expect to use MSA? And I've already sort of touched on this a little bit, but let me emphasize. There's 2 fundamental ways. The first way up there, I'd suggest, is the more tactical way, i.e. we've proven it out. There is a few thousand pages that talk about what the design decisions we made and why, how we built it, how we tested it. So if you're embarking on some kind of IT implementation project, let's say for a PKI rollout, or a customer wants a new data center environment, or they're rolling out Exchange Server 2003, there is going to be guidance here that helps you architecturally, it helps you as an implementer, it helps you as a tester, and it helps you through that process of getting to the right solution. So I'd say that's the tactical approach. The reasons why I stress that this is not what we expect you to implement are given here in some of the examples as to why we expect customization. Numbers of web servers. So if you talk about architecture, we've no idea how that architecture is going to be used, what type of applications you're going to put on it, how do they load the web server, what kind of middleware requirements have they got. There's no way we can propose some architecture that's going to be a one-size-fits-all. So things like the numbers of web servers, the numbers of database servers. The second one, firewall rules. I'm sure there's no two customers in the world that have got the same firewall rules for who can communicate with who through their architecture. Obviously needs to be customized. And then integration into existing environments. That's something that we've not got around to doing the work on yet. We really want to. But architecturally, you've absolutely got to think about how you integrate with Unix systems and your back-end mainframe systems. And then secondly, standardization. So we've worked with a few customers. One example is Quest. So we've worked with Quest around the concept of producing what they called a standard operating environment. Is that a term that anybody's familiar with or uses, standard operating environment? There are a few permutations on it. Some people call it sort of technology architecture in the context of enterprise architecture. Or the common operating environment, standard operating environment. Generally what it boils down to is the contract that needs to be in place so the expectations are set between the business guys that write the solutions and the IT guys that support them with the infrastructure. So we've had a few customer situations where our guidance didn't get used tactically to help them build it, but it got used strategically to help them develop this contract. In one example of an IndyMac bank, who is a very large online retail mortgage organization in Southern California, they used MSA not only to build out their data center, they were building a new facility, but they developed what they considered to be their contract. Now, it was a means for them, to go, as the IT guys, to go to the business and hold up their statement of what service they offer and how the solutions can leverage IT infrastructure. So what I mean by that is, so high availability SQL Server, when you've got application guys that are worrying about putting a solution together, that should be transparent to them, the fact that they've got a highly available database service. They shouldn't have to worry about, is it going to be a cluster? Am I going to have two? Is it a read-only configuration? How does that work? Is there two NICs? You know, all the questions that are there around the IT infrastructure that the application guy shouldn't own need to be in this contract. And that's what IndyMac Bank used as a basis to, in effect, push back, to, in effect, say, no, you can't do that. We have an IT infrastructure that adheres to this standard, and please adopt that standard and leverage it, and you will benefit. The hero from that situation was the operations guy, because instead of having a solution thrown over the wall, and he was responsible as a group for rolling it out into production, now he got something that, in effect, it's like a compatibility issue, isn't it? An interop issue. He'd got a solution given to him to the responsibility to roll it out in production, and they are literally doing things in weeks now instead of months because the issues aren't arising. They're not putting a solution out onto a cluster and then finding out the application developer didn't make it cluster aware, so at failover it crashes. You know, it might be a simplistic example, but that's the kind of thing that often the operations guys find out, that the IT infrastructure and the business solution don't match. And we've had a few occasions where customers have benefited. So tactical and strategic use of MSA. So now I've gone through all that, I sort of want to build up a few screens to talk about the architecture itself, some of the details of the architecture, not necessarily pure technology aspects, but the thinking behind it and the way it happens, and the thinking that we can apply, and you can apply, when you add IT services into an infrastructure. So the first thing that we think about, which is in effect our architecture blueprints, is the zoning, security zoning. Every organization, whether it be simple or complex, is going to have some kind of separation with their environment. Even a simple organization is going to have some public aspect and some private aspect where they want some separation of environment. This is actually a lot less than we have in our environment, but physically, but logically it represents that. Things like a border network, where your routers are for internet access, the perimeter, where your IIS servers might reside, then internal data and applications, internal infrastructure zones, remote access, satellite branch offices. These are all segmentations that you want to make in an environment because you deliberately want some kind of separation for security reasons. Right? So that's the first tier of thinking in terms of how you segment your infrastructure. Once you've done that, you've obviously got the issue of, well, fair enough, I need to segment my infrastructure, but I've absolutely got to allow some communication, otherwise nothing's going to work. So I need to overlay then some kind of networking architecture onto it. So this is where we worked with Cisco to talk about best practice network architecture. So issues like, so there's two fundamentals here, I'd say. Firstly, the architecture of the network. Concepts like aggregation switching, core switching, perimeter switching, the fact that you've got this tiered approach to switching. Why would you do some of that? A lot of the blades that you put in switches are very, very expensive. So in a switch that's got a lot of high churn, i.e. where you plug your users in, you've got a lot of change going to happen on that switch and potential, maybe say, reboot on that switch. You probably don't want your really expensive cards in there. You want them in some kind of core switch where it's not going to get too much change on it. So you centralize your expensive cards. So that's one of the reasons for doing this. And then it just makes sense to distribute that where you've got a lot of client connectivity to deal with. Distribute that around your infrastructure. The other aspect that we need to deal with here is once we've zoned like this, we've got inter-zone communication issues to now to deal with, and we've got intra-zone issues to deal with. So if I'm a database server on the back end here, I absolutely need at some point to communicate with an IIS server that's going to be a front end if it's an application that needs that, obviously. So that kind of gives me implications there on not only what kind of switching and routing that I've got to provide, but I want a firewall in between that because this is the perimeter. Right? So I've got a firewall blade in my network device there. So you can see how this is all building up. And not only does it build up on the basis of security, networking, services, manageability, those kind of things, but security is embedded all the way through this, because every time that I make a decision about what can happen in this network, I'm also making a decision about what can't happen in the network. I absolutely want communication to only go between the devices that need to communicate and only in the direction they need to communicate. So you can see now that I'm sort of building layers up of the defense in depth I was talking about earlier. I'm making zones, I'm laying on a network infrastructure, and as part of that, all the segmentation that I'm doing is part of my security architecture. So once we've got the plumbing right, if you like, the way that we've segmented our network, we can then start thinking about adding further services. So now the plumbing allows us to distribute services, but distribute them in a very intelligent fashion. I've got these limitations in terms of what zones can communicate with what, but I've got requirements for services in multiple zones. Let me explain that. In a perimeter, let's take Active Directory. In a perimeter, do I really want my company.com namespace to be exposed in the perimeter? You know, absolutely not. That's an insecure approach. So in the internal network, that's where I'm going to put my precious namespace, but I still need name resolution in my perimeter. And I still need authentication in my perimeter. The services that I need that are behind the firewall. Do I want to open the hole through that firewall? Well, absolutely not. Otherwise, it's just no point in having it there. So this is implying that I've got a necessity to distribute service. I need Active Directory and name resolution services here purely for the IT services that run in this location. Right? So can you see how the design is being formulated based on the architectural principles? So obviously I'm going to have a forest here. I'm going to have an AD forest back there. I've got Active Directory servers here. I'm so close I can't read it actually. I've got directory servers here and I've got directory servers in the internal network. Similar for DNS. So then let's take an example of that. When you put DNS in the perimeter for name resolution, there's also the advertising aspect of it. So you do advertising, you do resolution services. So you could take your security to another extent if you're very worried about things like cache poisoning. People can get into your namespace, even in the perimeter, and poison your cache. And even do denial of services attacks. There's all sorts of things they can do to DNS. We can split out things like resolution and advertising into separate services. So that's like adding an extra sort of thought process in terms of applying security principles when you design an IT service. So All the services we've got in here now, we've got things like VPN for remote access, proxy services for outbound internet access, firewall services, so this is the perimeter firewall, layer 7 with ISA server. These icons are the internal firewall. Other icons are the routing that's happening or the load balancing that's happening and the firewall that's happening. So there's many, many layers of protection. One note there at the top as well, we've had to think about the distribution of centralized storage services. So we've got a SAN environment, and that SAN environment needs to provide its storage in a controlled fashion. So it is also a way of architecting, if you like, a communications path within your environment. So now we've sort of laid out all these network services, we can start thinking more about application services. So that was just the core plumbing to make stuff work. They're not services that end users use. So now we can start thinking about more of the end user services and enabling those. So middleware and web services for internal applications. So this is your intranet. Right? So there's different requirement in terms of underlying architecture as to how you'd want to provide intranet services as opposed to middleware and web services for an internet presence. You know, obviously you've got a different set of users that you're catering to. You've got different security that you're worried about in deploying those services. So that's, again, the thought process. Other things, we've got things like PKI infrastructure there, various varieties of database deployments, whether they be for a read-only database, clustered, multi-node clustered databases, all that kind of guidance in the back end. And once the IT services are there, so hopefully now you're getting for this feel for the approach for thinking of how do we distribute IT services in this architected fashion. Once they're there, we've got to think about managing everything, obviously. The implications of distributing IT service and having this security architecture in place, we're making it hard for ourselves to manage the environment. Manageability and security are always a trade-off. So, examples, backup and restore. You might want to implement an enterprise-level backup restore solution. Are you going to have one backup restore facility in your internal network and back up everything with it? Well, if you did that, all of a sudden you've got a whole pile of holes that you need to open up in your internal firewall. So you might say, well, the manageability is good because I've only got one backup facility and I'm backing everything, but I'm not willing to take that security hit by opening up all the firewalls just to allow the backup service to get access to the perimeter. Right? So again, that's a design decision for how we deploy that service. And we actually have a backup service within the perimeter specifically for backing up the perimeter based on the policies that you decide. Right? And let me go back to Active Directory. A great example with Active Directory in terms of manageability versus security. There is a train of thought that says, well, yes, we'll have an Active Directory forest for our internal network, but for the perimeter, I'm just going to leave them out of a domain. They're just standalone servers because that's more secure. Now, I would agree with that statement. That is a very secure way of doing it because there's no domain for someone to hack into. But look at the trade-off. The manageability really, really goes down because you've not got Active Directory as a means to apply standard group policy to all those servers anymore. And that is a fundamental part of our defense in depth strategy. We want a consistent way to lock down our servers. So what we've done is implemented that forest in the perimeter for manageability reasons primarily, but we're confident that we've not compromised security either. Finally, once we've laid in all the services like that, we've laid in all the manageability requirements for those services, then we can start thinking about the impact of letting users in, whether they be nasty hacker type people that want to come in from the network or even customers, whether they be employees that are coming in from branch networks. As soon as you let people into your environment, boy, does that test your environment. Branch networking, for example, you absolutely want secure, controlled access via VPN services or secured in terms of certificate for branch-to-branch VPN communications. So those are the kind of scenarios that we're testing out. So hopefully by building that diagram and coming to what you've all, or at least most of you, have got as a diagram in front of you, you get a feel for the approach and the value of that approach in terms of how you end up with a design. contrast that with just standalone thinking about, right, I'm going to roll out Exchange Server 2003. If you're doing that without an underlying architecture, how are you going to take all these things into consideration? The security, the manageability, the availability. You just can't do it as effectively. So that's what we're saying with MSA. Roll out IT services in this fashion, use MSA as an infrastructure standard, and it will help. And the fact that we've got all the build guidance, the test guidance, that's just icing on the cake. That's great stuff. It's really going to jumpstart those implementation projects. So let me, for the sake of sort of repeating myself slightly, sometimes I think review slides are sort of just a means to repeat, but let me hammer home some stuff, and hopefully if you've still got questions on it, you'll use it as a chance to ask. So MSA is providing tested and proven technology architecture, Microsoft-centric, on currently available products. So we don't do anything which is saying, well, in Longhorn, this is going to be cool. There's tons of great stuff in Longhorn, and we absolutely want to make sure Longhorn's a better product by the work we do, but the guidance we give you now is based on the products that are on the street now and that you're implementing in customers now. We're a great blueprint for developing your specific standardized architecture. In any discussion around consolidation, standardization, this kind of contract between business and IT, there is some reference material here that will help that conversation. We'll also jumpstart IT service implementation projects. We don't particularly call out and emphasize the process itself, but hopefully from what you've seen in the way I built that architecture, the process is implicit in this architected way of thinking about rolling out IT services. MSA 2.0, which is based on Windows Server 2003, is available now. It's out on TechNet. It's online readable in TechNet, but also it's a download. Turns out to be about 50 meg worth of documentation, so you don't have to be patient trying to download it. There's a lot there. But it's out on TechNet now. The CDs that you've got, and if you haven't got any, I've got all the stuff at the front here you can look at. It's got everything we've produced on it. So it's got our Windows Server 2000 guidance, which was our 1.5, but it's also got this new MSA 2.0 guidance. There's also training materials, presentations, case studies, there's all that good stuff on there as well. So there's just about everything you need to know on that CD. Feedback. Obviously, I've said, we work with partners, we work with the field. My group is sort of 20 people, so we're not necessarily big enough to solve problems like this all on our own. We go out to the field, because that's where we get best practice from. We've had people like CGY work with us, Avanard's worked with us, so we go out and formulate development teams so we can get best practice and get the opinions of people other than just Microsoft people, so that we can make it the best we can. To that extent, feedback to us is absolutely vital. If you get back and you get a chance to read this or form an opinion on it, please feel free to feedback. And your feedback could be, you are absolutely wrong in this. You know, we'd love to discuss that. Or, you ought to be doing this. You ought to cover this scenario. We're really, really interested in that stuff. And these aliases are all on the CD. The alias that's not on the CD is mine, because I don't particularly want to, you know, tell the whole world and have them email me. But as a result of this conversation, if there's anything you want to follow up with afterwards, then please feel free to email me. If there's any contacts you want to get, you're thinking about certain partners, either yourself or partners you work with, you want to find out what they've done globally, then I can certainly fill you in more. So please feel free to ask. Feel free, when we've finished, to come and have a look at the kind of guidance. You can just browse through these books. We don't print out much. I mean, this kills trees, basically, so we tend to prefer the electronic format, but we do have some printed copies. And if you haven't got the CD, then there's more at the front here. So I've really said a lot there, and the thing that most people struggle with a little bit when they're hearing the MSA type speak is, we're not talking about a product here. This is not Microsoft talking about a product or a technology. We're talking about an architecture, and that's a little bit new. And sometimes people struggle to understand precisely what, why, what do I do with it. I'd love if you've got any questions now, or if you've got anything that's sort of saying, but I still don't get this or I don't get that, please ask me. Is there anything?
Yeah, presumably you're constantly reviewing this guidance until you issue MSA 2. How frequently do you review?
So the question was around the frequency of reissue of guidance. So the very nature of architecture implies that it's not something that should necessarily be changing quickly. Otherwise, it's very difficult to use it as a reference. So fundamentally, our major architectural changes are on the back of platform product changes. So the recent MSA 2.0 with Windows Server 2003 can't commit to this, but it's very likely that the next sort of the 3.0 of MSA is going to be based on Longhorn, which at the moment we're talking 2006 or whatever it is. So we have like long change cycles for fundamental change, but obviously products change. And I mentioned earlier ISA Server 2004. That's going to be a great improvement product-wise, and we would absolutely love to put some guidance out based on that. So we're at the moment planning a refresh of our content for June next year, which is going to have a lot of the internal security updates that we're trying to get into the service pack of Windows Server 2003, and also have ISA Server 2004 in it. So really, the answer to your question is, we've got long-term changes, i.e. the 2.0, 3.0, 4.0, and then our more incremental changes are really based on changes that a product has. We don't necessarily update it just because a version of firmware has changed on a server. That's too low level of granularity. We incorporate it. We run a permanent bug database in the guidance. Anything we get in terms of feedback is something that can theoretically go into that database. And every time we have a release, whether it be a minor or major release, we triage those bugs and make the changes. Some of the, I must admit, quite a lot of the feedback we get is a bit more, you know, on this page, this diagram, and it says in the text that, you know, this is it, but your statement's not quite right. It's sort of that thing that we get. And we'd love to get some more dramatic things, people saying, you know, I completely disagree with where you've done that, or you've not covered this scenario. How can it be real if you've not covered that scenario? Because that gives us the kind of prioritization we need as well, because there's so much that we can, you know, attack in terms of giving good guidance that we've got to prioritize where we go next. So we do take it on board and triage it. Was there any more? So, yeah.
How would you position the deployment guides of, for instance, compared to this?
Yeah. So the question is around the deployment guides of the products, right? So the Server 2003 deployment guides, my opinion, I mean, yes, I'm biased, I work for Microsoft, but trying to be as unbiased as possible, I think they're best deployment guides that there's ever been with the OS platform. They're really very good now. But I will also say they're not deployment guides that are in the context of an end-to-end IT solution. They go so far, and what we try to do is go that bit further. So if we've got anything in our guidance that is a complete cut and paste or copy of the deployment guide, we've kind of wasted our time and money a little bit, and we don't want to do that. So, and there probably is a few circumstances down at the deployment level where we have got a little bit of overlap. If that overlap conflicts in terms of recommendation, wow, that's bad. If it doesn't conflict, then we've just wasted a bit of time, and in the next revision to the guidance, we'll make sure we don't do that again. So we're trying to provide that layer of value above and beyond. Because if you think about Windows as a product, yes, it's a deployment guide, it's very comprehensive, but they have to think about slices of guidance, yeah? File services, and they go and drill on file services, but they don't necessarily drill on that based on the fact that you've got certain storage, you've also got a PKI infrastructure, you've got XYZ service, you've got a whole pile of services, and what we do is put them all together and test them. So it's what we do in the lab, I think, really differentiates us, in that all that integration stuff comes out. Like we always include the product groups, and that's the key thing. We don't ship guidance unless a product group, unless our support organization, unless our own internal IT guys all say that's good guidance. So we're not trying to sort of go it alone and, you know, swim upstream. Complementary. If you've got any, if you look at it and say, but this is just like the same, please let me know, because we don't want to do that. So is there any more questions? Can I, sorry, go on.
What's the format of the online version?
Of the, sorry?
The online version. Is it the same format as the book, or is it hyperlinked and easier to access?
Well, it's just the book but put into HTML for TechNet. Are you familiar with TechNet? That's where all the IT pro guidance is. The technical guidance goes on TechNet. So it's exactly what's in the book, but it's just in online HTML readable format.
Is it hyperlinked, or does it
I'd say it's like reading a book, but yes, there are hyperlinks injected in there, but I would say it's nearer to reading the book. Are you looking for a different sort of experience or a better way of getting access?
But to know how it is, though.
Yeah, I'd say it's very similar to the book. It's laid out in terms of reference architecture kit, and underneath that you'll see architecture blueprints. Underneath that you'll see chapter 1, chapter 2, chapter 3, chapter 4. So it's very much like seeing a book, but in an online format. We have actually, on the CD, we have actually tried to implement some slightly more effective ways for people to get the guidance that they're interested in. Let me just stick the CD in. Let me just call out a couple of things because I think it's worth seeing. So this is the CD that you've got. So on the CD you'll see MSA 2.0, and if you scroll down, there are a couple of thumbnails there for two different ways of viewing the guidance. You can either view the guidance by an architecture diagram, or you can view it by a documentation map. So this map is literally just a map of all the documents that we've got in the documentation set. And from there, you can see architecture, implementation, blueprints, planning, building, and you simply click on that map to reference the piece of documentation you're interested in. Or if you weren't to use that technique, and the one I particularly like, is using the logical architecture itself. So you can obviously pan and drill around this. And again, once you find the bit you're interested in, you can either view the architecture piece relevant to that, or you can go straight into the documentation relevant to that. So using the diagram as a way to navigate. And I think that's much more intuitive. Unfortunately, TechNet's not like that because we can't just sort of change TechNet overnight in terms of the way people navigate. But hopefully from the CD, you'll be able to navigate and benefit from that much more so. So this is the storage devices documentation. And if I get down to table of contents, you can see this sort of pretty consistent approach we've got. So the device design, all sorts of options, and then going things like availability, security. All the documents have got a similar structure. Right? So if you're just worried about availability, it should be very easy for you to discover all the availability on the services that you're interested in, or the availability discussion. And so we try to be incredibly structured with the documentation set to make it easy to find. Number one feedback item from what we've done in the past, too hard to find. So we've tried to address that. And you know, if you look at this stuff and say it's good to find, it's easy to find, or it's still hard to find, again, please let me know, because we're always looking to improve it. So is there any more questions?
Well, this relate to the SDN product that will see the
Yeah.
set of templates that you can use then?
Yeah, so the question was about SDM. I don't know if anybody's familiar with that, but it's part of the Distributed Systems Initiative. SDM, I can't remember what it stands for, something System Development Model. So that's all templates, frameworks, etc. It's also, in terms of automated deployment, what's available now is the ADS toolset, the Automated Deployment Service. So yes, we work very closely with that team. Internally, they're called the Big Group. I suppose the DSI is their external name. We work very, very closely with those guys because we've developed a lot of enterprise scenarios, and obviously what they want to push their stuff forward is good, proven enterprise scenarios. So we're very close to those. I would argue that that is sort of the strategy for the future, and what you're looking at now is what can help you now. Yeah. So, I mean, that's fundamentally a lot of what they're trying to do is going to be realized around a Longhorn time frame. So any more questions? Okay, well, thanks for your time. I hope you've learnt something from it. I hope I've reached my goal of at least making you think, there's something I need to go away and look at there. Because if you think that, then that's a good thing. Thank you.